We're now ready to examine normal stimulus and response for SMTP, and rather than focus on a single isolated scenario of how SMTP works, we're instead going to go and look at a much broader scenario of how it works really in a more real-world practical situation. So we're going to focus on the diagram on the screen here and go through this whole process. So in this case, we have two networks, the Skynet network and the Cyberdyne network, and we have a user who wants to compose an email and send it to a recipient from one network to another. So the sender in this case is the Windows machine all the way to the left, 172.16.16.225, and the recipient is the machine all the way to the right, 172.16.16.235. So we have to cross our network here, which means we have to send mail to our local mail server, which then sends it to a recipient mail server, which the client or recipient can then retrieve that message from. So that's the process we're going to go through here, and we're going to go through that in a few different steps. So I'll actually talk about a step here while referencing the diagram, and then I'll show it to you at the packet level, and that's when we'll really dig into SMTP and show you some of the commands being issued and the responses coming back and what these messages actually look like as they're being transmitted. But know that we're doing it in reference to what's going on here, and we'll be looking at captures from different points on the network, and I'll of course tell you where the packets were captured from as we look at each one and start to go through them. So first up, let's start with step one here. This is when the user sitting at the terminal at 172.16.16.225 has decided they want to send an email. So they open up their email client, they type it up, and hit the send button. And that's where we're going to start our capture from. So our first capture was taken from the sending device. So we're going to take a look at that and examine what that message looks like as it's being sent to the local postfix mail server for Skynet.local, the Skynet network, at 172.16.16.221. The first capture we're looking at is called Mail Sender Client 1. This is the first packet capture in the sequence of SMTP captures we're going to look at, which is why that number 1 is there. You'll see that increment as we go along. And this is, again, capturing the mail message that's being sent from the client, so from 172.16.16.225 to the mail server, which is 172.16.16.221. Now, SMTP relies on TCP for transport services, so we have an initial TCP session setup, a TCP three-way handshake that occurs right off the bat here. We see send, senac, ac. This is going to the server on port 25. So that's the port most commonly associated with SMTP, and the one you'll see used there, which is what Wireshark tells us as well, with the transport resolution turned on for the ports there as well. Now, after the three-way handshake is established, the server sends a packet back to the client, which is really the first SMTP packet we're going to look at. Now, here below I've expanded the SMTP header, and there's really not a lot to this, and that's going to be kind of a consistent theme. The SMTP packet is not overly complex. It's pretty simple, really. We just have this concept, remember, of commands and responses, and this is actually a response. Even though there's no command sent, this is actually a response presenting the SMTP server's banner to the client and saying it's basically ready for connections. Now, in this case, we see the response code 220, which means service ready, as is described here. It says domain service ready. And the detail provided with that is mail01, which is the name of the server itself. It's the host name of the mail server. ESMTP, which tells us that this is using the extended SMTP configuration and can accept extended SMTP commands. And postfix, so we know it's running the postfix mail server application and that that's running on Ubuntu Linux. Of course, this line is terminated with a CRLF, so carriage return /r line feed /n, which terminates the line in this case. And that's really, for the most part, that's really it as far as this particular response code. Now, next up, the client in this case, so 172.16.16.225 in packet 5, sends a command. And this is the first example of a command we're seeing sent in an actual packet. Here, the command line is elo. Elo is a hello command. It's a one used with extended SMTP. So we talked about the hello command. This is the same type of thing, but for extended SMTP. So ehlo, and it provides, in this case, its own IP address in the command. So that is sent to the server. That packet is acknowledged. We see that in packet number 6. So we see the TCP acknowledgement. Nothing to see here. And then we see another response from the server, and this one's got quite a bit more information. And if you look, it actually has several response codes. I'll go ahead and collapse these here so you can see them all together. In this case, we have several 250 responses here, and they have a lot of different information, so that's pretty cool. Now, 250 in this case means requested mail action OK, and we're also providing some parameters. And let's look at some of these now. We have one that has mail01, which is the server name. We have one that says pipelining, one that says size, verify, and so on. What we have here is the server actually presenting to the client some of the commands that it actually supports. So it supports things like start TTLS, which will allow this conversation to be taken over into an encrypted channel. It supports verification of sender addresses, so we can actually verification of recipient addresses, so we can verify if address we're wanting to send to actually exists first. Different things like that. These are all different commands that are supported by the SMTP server here. Now, once this is sent, the client knows what commands it can use, and really our communication can begin in earnest. This is when we can start talking about sending mail from the client to the server. Now we can continue analyzing this as we have been. We can go packet to packet, look at the SMTP header, so on and so forth, and keep doing that. But quite honestly, I think there's a little bit better way. And this is not something I'm going to tell you to do with every protocol all the time. But generally speaking, when I'm analyzing SMTP communication, I'm not doing it from the packet list and packet details window. I'm actually going to follow the TCP stream and do it that way. I just think it's a lot more concise way to do it. And really, there's not a lot of extraneous protocol information with SMTP that won't be renderable within that window. So to do that, I'm going to right click on this SMTP data here. I'm going to click follow TCP stream. And this will actually give me a display of the entirety of the communication that's going on for the SMTP application layer data within this communication. Remember, when following these streams, it rips out all the application layer data and compiles it all together here. And it also color codes it in this case. So anything that's blue here is sent from server to client. Anything that's red is sent from client to server. So that's what we're looking at. And you notice we see a lot of the same things we already saw. Here is our banner advertisement. Here was our elo command. Here was some of our supported parameter commands from the server. And notice when I'm clicking on things, it's actually bringing me to the packet that it's represented by back behind this. So if you need to go to the individual packet, you can certainly do that as well to examine the other layer information. So that said, we're ready to talk about the process of actually sending mail from the client to the server, and we can do all that analysis right here from this window. Sending mail in this way is not really too tricky of an endeavor. We just have a few specific commands that have to be sent along with the data related to the message, and then in that case, we're ready to go. That's all there is. You see there's not a lot of data present here other than the actual email itself. So let's actually step through that. Now, the first command we see here is mail, and that's mail from. So from is a parameter of the mail command in this case, and the mail is from sanders@skynet.local. That's the email address of the sender in this case. That's the person who's sending the email. And we also see a size parameter, which tells us the size of the message. In this case, 556 bytes. So this is the first thing that indicates we're sending a mail message, and the server responds to that with 250 OK. So it's telling us that this is OK. It's received the message, and we can continue sending. Next up, we have the receipt to. Receipt, or in recipient in this case, to is a parameter of that, and we're saying recipient to sanders@cyberdyne.local. So we're going from sanders@skynet.local to sanders@cyberdyne.local. That's who we're sending the message to. The server responds. We get another 250 response code saying that that's okay and everything's good to go. Now, those follow the convention we've talked about thus far with commands and response codes. The next one we're going to look at is just a little bit different, but it's very important, and that's the data command. Now, you notice this command listed here, sent from client to server, doesn't have any parameters associated with it. The data command is sent when you need to send command over to the server, and the server is going to respond with code 354. And that basically says, okay, I'm ready to receive data. When you're done, end it with CRLF period CRLF. And this is very important. What it's telling the client is start sending me your data, but when you're done, send this specific string of a carriage return and a line feed, a period, and another carriage return and a line feed. If you do this, I will know that you're done sending data, and I will acknowledge that the data was then accepted, right? Because we can't just have it be a carriage return and a line feed, because there's a lot of cases where we may actually have legitimate CRLFs in the message we're sending. So it has to be CRLF, 2 of them with a period in between. So that's what we're looking for here, and that's to some degree the delimiter that the server is using. Now, once we do that, really that's pretty much the gist of it from the server. We're ready to start sending the contents of the email, which is what you see in this big blob of red data right here. And we saw all the different things associated with the email. We see to Chris Sanders, Sanders at cyberdon.local, from Chris Sanders, Sanders at skynet.local. The subject line is help. We see a unique message ID, which is used by the used to track this particular message. We see a date. We see a user agent, just like HTTP clients have user agents, so do mail systems. We see this is sent from Mozilla Thunderbird in this particular case. We see content type. It tells us it's just plain text in this case. Encoding, if there were any to be concerned about, but that's all listed here. So things that the server can use to process the message, or at least the recipient mail client can use to process the message when it needs to. And then we see the final message itself. I need your help. The system has become self-aware. On second thought, why am I sending this from a system that can most certainly intercept it? Oh well. Well, I guess the sender of this should have been aware of what he was doing in terms of system visibility. But nonetheless, that is sent. And then right here, we see our period. So we see a period. You can't see it here, but there's a CRLF right at the end of this line. There's one at the end of this period. And that indicates that the message is complete, has been sent, and it's done. So this will be at the end of the packet sent to the server. The server responds with a 250 message. Again, everything is okay, everything's great. Tells us it's queued the message with this particular ID number associated with it, and that's really it. The client is done transmitting its message, so it sends the quit command with no parameter specified, and the server responds with 221 by completing out the sequence here. Now, if I close this, we have the by selected here. We see quit. We see by right here. And then we see our series of finac, ac, and then the connection is closed. That's the end of our communication. So you see what we did there. Again, I think it's just so much easier to follow a TCP stream to look at SMTP data because it gives you everything right here. You're not spanning through all those packets. Of course, if you need to go to them, you can go to them very easily to look at the lower layer protocol information, but pretty straightforward. SMTP is not too complicated of a protocol once you realize the flow of information that's going on here, and particularly how data is transmitted with this data command and the delimiter in this case, which is CRLF with 2 of them with a period in between. So we kind of see what's going on there and we understand that process, and that really completes our understanding of the first step of the scenario that we're going through, wherein the sender sent the message to their own mail server. All right, so we just looked at step 1 in this communication process, and that was our client sending to its own mail server, and we collected that from the client. Now, the next step in this process is to track what happens on the mail server itself. So on our local mail server on skynet.local, which is 172.16.16.221, we're actually going to perform a capture from that system to see what happens once it gets the message. Of course, its purpose in all of this is to receive the message and get it to its destination, which means it's going to forward it on to the postfix mail server for the cyberdon.local domain, which is 172.16.16.231. You see the difference in the networks, right? So one segment, the last octets are 2, so 221, 225 versus the other network, which is 231, 235. So Skynet is represented by 2, Cyberdon is represented by 3. So in this case, this is going to be step 2, and we're going to look at the packet capture taken from the postfix mail server for the Skynet network. Now we're looking at mail sender server 2, which is the second packet captured in this case from the local mail server from the sender. Now this is going to get a little bit more complicated in the fact that we have a couple different conversations going on. As a matter of fact, if I go here to statistics conversations and look at the TCP tab, you'll see we have conversations going on between 221 and 231. And also between 221 and 225. So we actually have here this bottom conversation is what's occurring between the mail sender, that client, and the local mail server. And then this top conversation is occurring between the local mail server and the remote mail server. So that might get a little confusing. So I want to do a little trick here, which I think will help us out as far as keeping things clear, understanding what's going on. So let's go ahead and do a little customization. Now, to do that, first, I'm going to go ahead and let's colorize these conversations a little bit. I'm going to right-click on this conversation. We're going to tell it to colorize. I want to colorize the TCP conversation, and we will make it red. So we can very easily see where the first conversation begins and ends. It looks like begins in packet 1, ends around this area. So it's actually ending after another one is starting. We see our second conversation is happening here. So I'm going to right-click it, colorize conversation, TCP, since we're doing it based upon the TCP communication with the different ports that are used, source and destination port pair. And let's make this one green so it stands out even more. So you can see here where our first conversation is red, our second one is green, and they kind of interweave right here in the middle of this capture. So that's why I did that, so we can keep that portion of this straight. Now we're going to go ahead and dig into this by looking at the first conversation now that we've clearly delineated where it is. Now, this is, again, from 172.16.16.225, which is our web client, to 172.16.16.221, which is the local mail server for that network. Now, I'm going to go ahead and right-click this, and let's follow that TCP stream. And I want you to see if you notice anything that looks of interest to you. Now, if you look at this, you may say, wait a minute, this looks really, really familiar. And that's because it should. This is actually the exact same packet stream we just looked at in the first capture. Remember, we're capturing the same communication, but from two places. We captured from the client and saw it sending to the server, and now we're on the server and we're capturing the same communication just from the server's perspective. So we're going to be seeing the exact same thing, right? In this case, it's just from a different location, but everything should sync up. And if you want to, you can actually go through the process of comparing the checksums and the packet IDs and things of that nature to make sure it's absolutely the same one, but I will go ahead and save you some time and assure you it is. So this first conversation, we're not even really too concerned about it here because we've already looked at it. We've already analyzed it, and it's just showing that the server is indeed receiving this message. So if we were troubleshooting this for some reason and we wanted to make sure that this was actually received, I mean, obviously we saw the TCP ACKs and things like that, so we should know that from the client side. But if you just needed to compare and contrast things to see if packets are maybe getting corrupted in transit or something like that, maybe packet contents were getting inverted in such a way that it didn't mess up the checksums, I suppose you could look at that here as well. But for our purposes, we're just not as concerned about that. Now, we know that the server received the message, but what happened after it received it? It's supposed to get it onto its destination, and it's not going to do that by sending directly to the recipient because the recipient's on another network. It's not responsible for holding the mail for that recipient. So it's actually going to send it to the recipient's mail server, the mail server that is responsible for holding that communication. And that's this green conversation that begins right here in packet number 22. That's where we see the process of it sending from one mail server or local mail server to the remote mail server. Now, the thing you don't see here is, answering the question, how does our mail server know the IP address of the remote mail server? In this case, it has a static route set to it, so it knows it because of that. In a real-world scenario, it would rely upon DNS to find it. So it would traverse the DNS hierarchy, making a special query type called an MX query, mail exchange, to find out where that mail server exists. We don't see that here because we're just using a static route for this specific example. Nonetheless, we can still continue forward. Now, once again, we have another SMTP communication. We're going to port 25. We have our three-way handshake being established right here in packets 22, 23, and 24. Skip a couple of these fins from the previous conversation, and we get to packet 27, which is where we see SMTP communication being established. And it looks like this case, we have a response, we have a banner sent from 231, which is the remote mail server, to the local mail server, 221. So again, I'm going to right-click this and follow the TCP stream because I think that's the best way to examine this information. Now, if we look at this data, it's going to look pretty darn similar to what we've already seen. After all, it's the same message. It's just being forwarded via the same protocol to another system. So we shouldn't see a lot really different, right? It should be pretty much the same, and for the most part it is. We begin with the banner sent from one server to another, from the remote server to the local server. We see elo command, and the server is, in this case, identifying itself as mail01. We get a response back from the other mail server, which is conveniently named mail02, so that's the remote server. We get a list of acceptable commands that the remote server is willing to support. In this case, it's also a postfix server running on Ubuntu. I can tell you that they were actually the same server. I set them up together in the same way. So they're going to support the same commands, which is not what you're going to see all the time, but that's what you see in this particular example. And then we see the commands that are used to initiate the message transfer. So we see mail from Sanders at Skynet.local, recipient to Sanders at Cyberdon.local. And then we see our data command, wherein we can start sending data. And once again, the server wants us to terminate that data with the 2 carriage returns and line feeds with a period in between. So we send that message, and we see it's the same message. There's a little bit of additional data appended to it in this case, since it's mail server to mail server, not client to server. But for the most part, it's the exact same message, right? So it's everything we expect to see. And then we see our period here, which indicates our CRLF both before and after that, indicating the end of the message transmission. The quit command is issued, and then the server responds that message is queued and responds with a bye, terminating the connection. So after this process is complete, what we have is that our message has been transmitted from the local mail server to the remote mail server. It is now being processed by the remote mail server and associated with the mailbox of the recipient user so that it can go and retrieve that message. So let's talk about that process next. Now that the remote server has received the message, we're ready for the final step in this process. And remember, SMTP is responsible for sending mail, not necessarily for retrieving it. So we actually have a bit of a different process going on here in this third step. We're going to look at the post fixed mail server for Cyberdon.local. So we're going to see it receive the message. So we're going to see the other side of the communication that we saw from the Skynet.local post fixed mail server sending the communication. We're going to see those same packets, but on the recipient side. And then we're going to see the recipient user actually pull the message itself from its mailbox via IMAP, which is going to be a little bit different process. We've not talked about IMAP, but I'll talk about it briefly as we go through this next packet capture and round out this scenario. I've opened a third capture file, which is mail receiver server 3. And this is taken, this capture was made from the remote mail server. So from the mail server responsible for delivering it to the recipient mailbox in this case. Now, once again, we have 2 conversations going on. We see the packets arriving from the local mail server to the remote mail server, which are the packets we've already looked at. And then we see the client downloading its email from the server. Now, in this case, you'll notice we have the 2 conversations. One is green and one is not. The reason this one is green is, remember, we set a coloring rule on the last capture, and we set that actually for the parameters of this exact sequence of packets just captured from another place. So that coloring rule still applies to this traffic, and thus has still been applied when I open up this new capture file. So that's all going on there based upon the coloring rule we've already applied. Now, if I scroll down, this other traffic down here does not meet the threshold for an existing coloring rule. That said, I'm going to go ahead and colorize it myself. We'll make it this nice shade of purple here so we can differentiate it. So we see we have 2 communication streams going on here, green and purple. Green is the first one. And again, this is traffic we've already looked at. We looked at this traffic when we examined the local server sending to the remote server. We're looking at the exact same traffic just from the perspective of the remote server. So I had packet sniffers running on all these things at once when I clicked send on that email, and we captured it at every point along the way, which is what we're looking at here in this particular communication. So in this case, I'm not overly concerned with this because we've already talked about it. So let's just briefly cover the next conversation, which is a little bit different. Now, up to this point, the server has now received the message. The server responsible for the recipient mailbox had received the message. It's associated it with that particular recipient, and now the recipient can actually go and check its email and pull that information down. And that's actually what we have going on here, starting with packet 16. We have 172.16.16.235, which is the mail recipient, initiating a request to 172.16.16.231. So this is a little bit different. Whereas with SMTP, it was a push. So we have mail client pushing to server and server pushing to another server. This is actually going to be a pull. So we actually have mail client pulling from its local mail server, which is how email retrieval doesn't have to work, but generally works with something like IMAP or POP3, which is what's going on here. In this case, you see we have port 143 being communicated with. So this mail server is not just listening on port 25, but also on port 143, which is commonly associated with IMAP, which is a protocol that allows clients to retrieve their mail from a mail server. So we have a 3-way handshake here, and then we see the IMAP protocol at work. Now, we haven't talked about IMAP. I can expand this a little bit here, and we see we have a few different things going on. We have some different commands. I'm not going to go through this whole process and explain IMAP in depth. That's a little bit beyond what I want to talk about here, but I do want to mention one thing. And notice here in packet 15 how we see start TLS. We know that TLS is an encryption protocol. We saw it used with HTTPS, and in this case, we're going to see it used with IMAP. So we're actually seeing secure IMAP here, and we see a lot of the same things we saw with HTTPS. We see client hellos, we see server key exchanges, we see the coordination of cipher suites, all those different things are going on here. And then after that, what do we see? Well, we see encrypted data. And if I actually follow this stream, we'll follow the TCP stream for this. We see certificate information up here and some commands being exchanged. We see the beginning of TLS negotiation, and then after that, we just see a bunch of encrypted data. That's because the client and server have negotiated the use of TLS encryption over IMAP to retrieve this message. So we can't actually see this data. We could view this from the client as well. We could have taken a capture from the client as well and seen this same thing. We would see encrypted data. So without having the appropriate cryptography keys to decrypt this traffic, we're just not going to be able to see the message. We don't have to see the message in this case because we've seen it in transit. SMTP in our case was transmitting that in the clear. Of course, that's not desirable. You want to be able to transmit messages encrypted, and there's certainly methods that can be used to do that as well. Although in this scenario, they weren't particularly used, so we could actually focus on dissecting the particular protocols. So that said, that really rounds out our scenario. We've seen the movement of packets all the way from the sender on down to the recipient. So just to recap this one more time, everything we saw. A user on our sending system, so the Windows machine all the way at the left, sent a message to a recipient user, our recipient machine all the way on the right. To do that, it had to send that message to its own local email server. That email server then had to send it to the remote email server that was responsible for the mailbox associated with the recipient user. And then that recipient user downloaded or pulled that message using IMAP from its own mail server. So we had a complete view of the email ecosystem here in terms of the interplay between protocols like SMTP and IMAP, servers talking to other servers, and so on. So hopefully this helped you understand the normal flow of SMTP communication as it might exist across your own network or networks that you're examining.